Right, all the surfaces hooked up. Got rudder. That's pull. Sort of see down in there. It's a bodged up tail wheel. Elevator. That's just a push-pull carbon rod. And then obviously ailerons. The servos just snap into place like most parts on the aeroplane, although I had to put a rubber band on there. The upper wing didn't secure in as tightly as I was hoping. Elevator servo sitting in there. So yeah, pretty much good to fly. So that's the cowling, it's 0.7mm thick, SLS printed. This is the guts of it. So the engine mount, or the motor mount, is sort of like a spring, and it's got keyhole snap lock features in there, so that's the sacrificial part. So in a frontal impact, it can bend through these elliptical springs and compress about 20mm, and the battery tray will slide back. I think it's got 30mm clearance before it'll hit the elevator servo that's just in behind the battery. And also under thrust, the battery tray, you can see there's got a T-slot, and then it's snapped into the back of the hole of the firewall to stop the elliptical springs flattening out as the thrust comes on. The firewall of the fuselage is about 12mm thick, with ribs and webbing all through it, so that's the part that's meant to save. The upper wing has got, you can see there, a sort of, not the best focus, a sort of keyhole fixture, so on a frontal impact the top wing will slide forward, hopefully the rubber bands. Hey, leave that, dog. The upper wing will slide forward. Landing gear is obviously quite a sacrificial part on remote control planes, so you put a rod in here and that is all printed in one piece. The landing gear can just snap out and a new one will snap in. Lower wing is rubber band fastened on. Rubber bands are sort of tried and true. So the lower wing sort of snaps in underneath this part here and retained in by the landing gear as well, and then rubber bands just pull out and around it onto this little wee fixture there. Yeah, all the CRG was all designed and tested for on SolidWorks with all the components, including spinner, prop, motor, battery. All electronics were all weighed, modelled in CAD, and then assembled into the CAD assembly model. And hey, don't chew the propeller. Stop. And so the CRG is going to be extremely close, straight off the building table. The only thing that wasn't accounted for was the covering, which is I've used a heavier covering than I intended to. And the wingtips are sacrificial as well. You see, they're quite in a cartwheel situation after landing. They can break away and then just clip a new one on. So I'm hoping it's and obviously, I mean, nylon's quite a durable material in the first instance, so it should be quite a long-lived model, even with my terrible landing and flying skills. Yeah, I'll get it up in the sky and hopefully get some footage of it flying. It's going to fly fast. It weighs, I haven't had the final weights come in, but it's going to be 100 to 200 grams heavier than the balsa version, which was quite a lightweight build. That's the Her Pit Special up there. That was a great little plane. I think that weighed 750 grams. Can't remember wing area, but I'll put all the specs on in the description of the video. Sweet.